A Bernoulli setting is really important when it comes to geometric and binomial probabilities, so let's get comfortable with it. Let's suppose we invited students to show up to begin a student advisory board. We got 25 seniors, 10 juniors, and 5 sophomores. We invited the freshmen, but they couldn't find the room. Freshmen. Anyhow, so what we're going to do is we're going to establish that one of these groups is the success and all others are failures. So, okay, we'll give seniors their props. So we're going to say the seniors are the successes, and then these would be the failures, because maybe we're just interested in saying, hey, what's probably randomly select 2 people to be the special group leaders of the week. What's probably the first one's a senior and the second one is a senior. All the others would be a failure. We'd fail if we got a junior because we were looking for a senior and a senior. Well, for this to be Bernoulli, then it has to be that not only can we separate it into a success and failure, so 2 categories, but it also has to be that the selections, the trials are independent of each other, which means that the probabilities wouldn't change. But if we say we're going to select 2 different people, then once we select one senior, then instead of us having 25 out of 40 seniors like we did originally, now it would go down to just 24 out of 39 seniors. The conditional probability changed, so we no longer have independence. So to have a Bernoulli setting, we have to be able to categorize into successes and failures. We have to make sure that the trials are independent of each other and that these probabilities don't change going from selection to selection. In addition, we want to represent a success by the letter P. So the probability of success is equal to P. So in our case, the original probability is 25 out of 40, which is 0.625 or 5/8. So this would be P. That's the probability of success. Well, then the probability of a failure must be 1 minus P. If this is 25/40ths is a success, it has to be that 15/40ths is the failure, and that's what we get if we add these 2 groups together. Now, if we got success, failure, we got P, probability of success, 1 minus P, probability of failure. But again, if these are truly Bernoulli, then from sample to sample, P and 1 minus P cannot change. We could make sure they don't change by saying this, hey, we're going to select 2 people, and each person is going to receive a gift card, but the same person can receive both gift cards, so we can select with replacement. So now if we do the probability of success, that's P, and the probability of a success again is also P, the success rate. These probabilities won't change from sample to sample, from trial to trial. So we got successes and failures. We've got independence of the trials. The probabilities don't change, and these probabilities are P for success and 1 minus P for failure. This paves the way for geometric and binomial probability.